All right, students, so on this table is 6 groups of rocks. So typically you would walk in the classroom and each table would have a group of 3 rocks. These 3 for one table, these 3 would be on another table, but we're just going to have them all here and talk about them as we go through. So a geologist can pick up a rock and tell a lot about how that rock formed. It can tell by the size of the crystals, whether it cooled quickly or slowly. It can tell by the color. As you can see, this rock that looks like a piece of cement, but this is a natural rock. And this other one, these are the same rock. They're called conglomerate, but really names aren't that important. It's origin that's important. They're both formed from lots of little pebbles and crystals that over time got glued together by minerals that are in the water and got lithified over a long period of time, go from minerals and which act like glue and water to these beautiful rocks. Now this one you notice is orange and this one is not. They're the same rock, but this one formed in an area where there was a lot of iron. If you go up north, you ever notice when you flush the toilets and things that there's orange stains around things? That's from minerals that are in the water. And those minerals act as glue, holding together little particles in the case of this type of rock. Now, there's a reason why there's 3 rocks at each table. And we'll get into that throughout this lesson. There's a reason why there's 3. And we'll get into that throughout this lesson. I talked a little bit about the crystals in this rock. Both of these rocks have crystals. But you can see that this rock has much larger crystals. And those much larger crystals tell us about the cooling process, how long it took for this rock to cool versus this rock. And then there's this shiny black rock, which basically has no crystals. It's called volcanic glass. And so just by looking at a rock, a geologist can tell a lot of information. I'm going to put this one back and this one back and reach over and grab this piece of rock. This is very, very light. It's way lighter than what you would expect. And if you can see, it has lots and lots of holes, vesicles. It has lots of places where gases were trapped in this rock. When those gases escaped, they left holes, and this rock cooled very, very quickly, but there was many gases in the rock, in the minerals that make up this rock. When they were finally released to the air, left a lot of empty spaces. So this rock is super light. I wish you could pick it up and feel it. This is a rock that when polished, a lot of people use it to make their skin nice and smooth. Okay. Now, some rocks, like this piece of limestone, okay, some rocks change into a different form when they are subjected to lots of heat and pressure. So when limestone, which is calcium carbonate, is subjected to huge amounts of heat and pressure, it will change into this rock, which is marble. So limestone, which isn't, super expensive, it's not as sought after in, kitchens and so on. It is used in some building, but this here, marble, after this rock is subjected over many years to heat and pressure, it will metamorphose or change into this rock, which is marble. The same thing happens to granite, which, God, we all know about granite. Okay, granite is so popular these days. Nice piece of granite here. A nice piece of granite here. And I've got another type of granite here. So if you know anyone that wanted a granite countertop, There's hundreds of kinds of granite. If you ever went to a granite store for granite countertops, you'd see sheets and sheets, all different colors. And the colors, this is mostly black and white. This has a lot of pink. This has a little bit of pink, lots of black and white. These are all granite. They all formed large crystals, which means that they cooled underground. But you can see they have different colors, and that's based on what minerals are making up this particular rock. So what minerals are in the area where the rock formed, that determines a lot about how the rock is going to look, how that rock is going to appear. When they make granite countertops, they just cut out huge amounts of granite, they slice it, they polish it, and like I said, you can pick many different combinations. Okay, now this rock here, I'm going to hit it with my thumbnail. I'm scraping, and as I'm doing that, little pieces of sand are accumulating on the table. There's little pieces of sand falling onto the table. So can you guess what this rock is? This rock is sandstone. And sandstone is just when bunches of sand are glued together by minerals in the water, over time they are lithified or cemented together, and you get this rock called sandstone. Remember our rock that's just a bunch of pebbles held together, the conglomerate? This one not iron rich, the other one iron rich. Again, this is a bunch of sand particles glued together by minerals in the water. This is a bunch of pebbles. And look at this one here. This is a piece of coquina. And instead of pebbles or sand being glued together, this is crushed seashells. So we know that this rock formed in a marine environment where there was lots of shelled animals. And so like I said, a geologist can pick up a rock and can tell lots and lots about how that rock formed. Did it form from lava, and did it cool quickly or did it cool slowly? Did it form from shells, crushed shells? So did it form in a marine environment? Did it form in an iron-rich environment? Did it form from particles of sand just being glued together? It is amazing what geologists can tell just by looking at a rock. All right, students, so for our exploration today, you're going to make a model of any of the rocks that we saw on the table this morning. So remember there was 6 groups of 3 rocks. You choose one of those rocks. You can tell the other students in the table that's on our assignment sheet, I chose, the red rock from group 1, or I chose the brown rock from group 6, because we don't want everyone making the same rock. Now, I'm going to go ahead and make a model of this rock. Okay, and as we make our models, what we are doing is kind of modeling some of the ways that rocks are formed in our world, in our natural world. Because where do all these rocks come from? You walk down a beach, there's all these different rocks. They have all different colors. They have all different shapes. They have all different minerals in them. How can that be? Okay, so this was the one that looked like crushed shells. It's called coquina, but the names really aren't important. Again, we're just looking at the big concepts. Okay, and I'm going to make a model of this coquina. I'm going to use some cornmeal, some oatmeal, and some marshmallow cream. Now, in making this model, I am going to mimic some of the processes that were used in actually making this rock. Okay? So in the first table in our assignment, you're going to actually tell everyone else what rock you're going to make. The second table, you're going to put a picture of the rock you made, and you're going to describe all the processes that you used to make that rock. Now, since it's so messy, I've started out, I've done the mixing of the oatmeal with the marshmallow cream to form this, but I want a little more of the yellow color, so now I'm going to put it into the cornmeal. And now I've made my model rock. Okay? What I did was I took marshmallow cream, I mixed oatmeal in with that marshmallow cream, and then I put a little cornmeal on it. And in nature, that is kind of how this rock is made. There's fragments of shells laying, laying in a river, laying in a marine environment. There's lots of shells laying there. There's also dissolved minerals in the water. Again, think about up north or somewhere where you've been where the water has left stains on everything, on the sinks, the toilets, everything. That's because there's dissolved minerals in that water. And it's minerals that make up rocks. And so the shells are held together, just like I used marshmallow cream, the shells are held together by minerals in the water. They act as the glue, as the marshmallow cream. And again, I just added some cornmeal just to get a little more of the yellow color. So what you're going to do is you're going to pick your rock. You're going to let all the other students know what rock you picked. You're going to make your rock, and you're going to record all the processes. Just use regular household things like barley, like lemonade mix, like basil leaves, anything you have in your house, mustard seed, brown sugar, chocolate chips. You can use anything. You've got orange lentils here. You can use anything you have as your pieces of the rock and try to make it look similar to the actual rock that you're using. If you're using this one, a lot of students for this one will use some hard candies and they'll crush them up and then they'll hold them together using some kind of, marshmallow cream or some kind of sticky syrup or something. Okay? So use your imagination. Use what you have in your house. You don't need to go buy other things. Just use what you have in your house. You're going to make a model rock. You're going to describe the processes you used. The processes are like action verbs, like I crushed some cookies. I stuck them together with some marshmallow cream. That's processes. Processes isn't I walked over to the counter, I opened my cupboard. That's not what I'm after. I'm after what actions did you use to make your rock. So you're going to record that with a picture of your rock in the table that accompanies this lesson. And then we're going to use that knowledge to then look at a diagram of the rock cycle. You're going to use the words that I give you to fill in the rock cycle diagram and answer a couple questions. And that's your entire Rocks online lesson.